Hello, everybody. Thank you for joining us today for this AI4 session. My name is Omri Greenberg, and I'm the co-founder and CEO of OneView. OneView generates synthetic training data to train machine learning algorithms, and we do that specifically for geospatial imagery. That basically means that we are simulating satellite aerial drone data in order to do so. And we will soon understand exactly what synthetic data is, but I wanted to start my talk today a bit differently. Now, as I was preparing for this talk, I came across this tweet, as you can see on the screen right here, published probably like a month ago from the Portland Streetcar Service. And I think that really helps to tell the story on what's happening to our infrastructure. So basically, you can see that our infrastructure is experiencing very extreme weather conditions. It's becoming way older, becoming less reliable, but still we are experiencing high demands that need to be fulfilled. So that basically means that we have to keep a high level of service and also safety in order to provide that operational excellence that our customers are used to. And as we need to keep that operational excellence, we are constantly monitoring and inspecting our infrastructure. And for industries such as the oil and gas, such as the utility sector, that have a vast physical asset base, that basically means spending billions on billions of dollars annually just to monitor and inspect that infrastructure. So just to put this in context, there are about 2.6 million miles of oil and gas pipelines in the United States alone. Now, those pipelines have an average asset age of 20 years, and 2/3 of the Americans live within 600 feet from a pipeline. So this infrastructure is located in high population areas, making its maintenance even more critical. We have more than 5 million 5 million miles of utility distribution lines. So just imagine the scope of maintenance of such vast networks, just to make sure that everything is running efficiently and safely. Now, we all know what happens when things start to fail, right? We are experiencing huge consequences. We are experiencing major oil spills. We see major wildfires. But also more day-to-day impacts such as power outages and unstable electricity grids. So all of those consequences, they result in loss of human life. We're seeing critical environmental damage that takes years to repair and rebuild. And also we're spending a lot of money on fixing that infrastructure and repairing the environment and bringing the environment back to its normal state. So this really underlines the importance of ensuring that our infrastructure does not deteriorate and fail over time. So in order to avoid such huge consequences, what we do is we are constantly monitoring that critical infrastructure. And as we do that on a regular basis, what are we looking for when we are monitoring that infrastructure? So we look for deteriorating and aging infrastructure. Rusted infrastructure, for example, costs the US oil and gas E&P industry $1.4 billion a year. In addition to that, we look for cracked pipes, broken or incomplete components on the utility poles. We look for decayed wooden poles, and the list goes on. We look for vegetation encroachment just to check for hazardous situations that could lead to wildfires and damage to our infrastructure. Now, according to Accenture, US utility companies spend between $6 to $8 billion annually just on clearing vegetation from overhead lines. We have third-party activities that result in damage worth of $1.5 billion annually just to underground utility damage. So we're talking about huge consequences that cost our economy lots of money every year. So when we understand the consequences, how can we try and prevent those failures? So as we said, we need to monitor that infrastructure. We have to do that regularly, but we also said that it's so vast that we understand that it's almost impossible to be completed efficiently. So we have to find new ways to carry out this task of manual inspection of assets. Now, as we are proceeding with and seeing the latest advancements that regarding to the availability of new data sources and the more openness of companies to adapt to new sources of data. So we're seeing more and more companies that are now starting to add into their portfolio other sources of data to monitor their infrastructure. So we see lots of adoption of high resolution drone data, but it's also ranging all the way up to large coverage from satellite data that is being frequently updated. So now when we are combining those methods into our daily processes, we have the option to monitor those very large, vast infrastructure and to do that in scale. So when we have completed this task, we actually end up with a new type of a problem. That now the problem that we have is we are facing huge amounts of data that we collect. Now, what we need to do is we need to make sense out of this data. We need to generate the insights that we're looking for from this data. Now, the only way to make sense out of this data and to extract those insights is by applying machine learning algorithms in order for us to do that automatically. So even though we are in an AI4 conference and the entire audience here listening probably already knows that very well, every time that we want to create and generate and train a new algorithm, we have to start with the good old training, collection of the data, and its manual annotation. And as we all know, we are not talking about a small amount of data. We're talking about tens, if not hundreds of thousands of examples of data that needs to be manually collected and annotated. And this is just to get us started. And in our industry, we are discussing about applications that are by nature edge cases, right? We are looking for that aging infrastructure. We're looking for missing bolts or the damaged components or the vegetation that climbs on the poles and so on. And so those are, as we said, those are rare by nature. Not alone, they are not being captured quite as often on imagery as we would imagine. So we won't have those tens or hundreds of thousands of examples to properly train our algorithm. Now, this is exactly where we come in as OneView. This is exactly the pain point that we sought out to solve. And we understand that it's not possible to manually collect and annotate that huge amount of data required, and also specifically when discussing about those rare and edge cases. So what we do at OneView is we are generating already fully annotated training data. Now, what we do is we use a method which is called synthetic data to overcome this data bottleneck. Now, what is synthetic data? Synthetic data basically means that we are not manually collecting and annotating the data, rather than we are generating, we are generating it per our customer needs, already fully annotated and ready for training. Now, the way that we are generating this data is by using tools, computer graphics tools and techniques taken from the gaming and film industry in order to create fully virtual 3D worlds. Now, from those 3D worlds that we are generating, we are rendering or generating those images that we look for, but not only that we can create the images that we look for, but we can also have them fully annotated because we know which objects we placed and where, so we can provide you with the annotation for those objects. Now, we can not only that those are being done automatically, so that means there's no human in the loop there, and they are error-free or pixel-perfect annotations, as we like to call it, but also we can provide you with more sophisticated annotations that ends up with better algorithms. And because we have full control over this generation process, we have the ability to create very large, diverse the training data set that can basically fit your needs. So when we are creating the data, the thing that we keep constantly in mind is how can we add more diversity? How can we have the data more widespread, to have more variation? So in order to support that variety, what we do is we allow full control over multiple key parameters that ends up in that very data set. So we have control over the sensors that we're using and its characteristics. We control the different scenes in which we are taking those images, the objects that we're placing and where do we place them, how many do we place, the relationship between the objects, the relationship between the objects and the environment, the weather conditions, and basically the list goes on, just so we could have the end result, which is a very varied data set, diverse, that was meant to meet your needs, to train your algorithm to detect any kind of use case that you have in mind. So when we gain that level of control of our training, it has a significant impact on our daily operations and basically also the quality of algorithms. So some of the key benefits that we have saw so far from using this method. So obviously, when talking about accuracy, from what we have experienced so far from utilizing synthetic training data, so our customers were able to increase their model accuracy by up to 25%. And they did that while they have reduced significantly the time to market, reducing it from months needed to collect and annotate the data into a matter of even a week. They had the option to address and answer to all of those edge cases that we've previously discussed. And they also did that while saving a major portion of their cost associated with the data acquisition and pre-processing. And I think that pretty much sums what everybody in the industry wants, right? We want to have better algorithms that can be deployed faster, and they would cost us less, and they would be unbounded by reality and would allow us to answer to any kind of question that we have. Okay, so in order to summarize what we have discussed so far, where do we see that synthetic data is highly beneficial for the energy sector? Again, so it comes down to when we are discussing about all of those edge cases, when we want to find oil leaks that comes out from pipelines or from storage tanks, when we want to be able to see rusted infrastructure, missing bolts, when we want to be able to see if we have damaged pylons or decayed wooden poles. So when dealing with all of those rare and edge cases, this is actually where we see the biggest benefit of using synthetic data. And obviously the list that you can see here on the screen is just a partial list that has an infinite use cases that can be supported by using this method. Okay, so the name of this talk is how can synthetic data can prevent the next big disaster. And I want to take everything that we have spoken so far and really wrap it around that. So when discussing about the big disaster, we know that they are happening due to edge cases. The synthetic data allows us to capture those edge cases and to identify all of those problems just as before they occur. We have the option to do the monitoring of our vast asset base, to do that automatically by applying machine learning algorithms that will be again trained on synthetic data. That would help us to reduce significantly the amount of spending associated with that monitoring of that infrastructure, and to better direct our field operators to best meet the infrastructure needs and not just to work by their work plan. And we also have the opportunity to have a short turnaround time to any new threat or any new emerging need that we have. And basically synthetic data is the only way to properly train our algorithm. And this is the only way for us to introduce a broad enough range of instances to train it. And basically, that would what help us eventually to identify any failing or about to fail infrastructure. And so moving on, and we're reaching towards the end of our talk today. So we have done lots of proof of concept studies to validate and prove the huge impact that synthetic data has, not only in the terms of cost and time, but also in the accuracy manner, that it can also improve the accuracy of our algorithms. And one of the most recent and largest study that we did was we have done a case study alongside with Airbus Defense and Space. Now, Airbus they are generating 100 times more data than 10 years ago. So they are dealing with huge amounts of data, and they understand that their customers needs to make sense out of this data. And they believe that synthetic data is the way to do so. And they believe that 90% of all training data sets will be compromised from synthetic data. And I think that's a huge statement made by them. But I have to say that's also where we believe that the industry is heading. So if you would like to learn more about our synthetic data, how it can help you to best monitor, inspect, and manage your infrastructure, so please reach out to us, and I'll be happy to hop on a call and do a live demo. Thank you all for listening, and enjoy the rest of your conference. Thank you all very much.